theorem will be discussed. As a recap, we have gone through the circuit elements, network topology, Kirchhoff's current law, voltage law and Ohm's law, methods of analysis which includes both mass analysis and the nodal method of analysis. In this particular, we are first going to discuss concept of linearity, then the discussion will be carried out for the superposition theorem. Linearity is the property of an element which is having a linear relationship between the input and output. So that input and the output are defined by the different terminology, like say the cause and effect, excitation and response. So there has to be a linear relationship. Now there are two main characteristics of this linearity, that it should satisfy the scaling or homogeneity property and the additivity property. It suggests that if the input is scaled by a factor, then the output will also be scaled by the same factor. So let's say if the initial input current is I, that is scaled to Ki level, then the voltage across the linear element, say resistor, will also be K times V, where say V is the initial voltage. The same relation holds true for the inductor or capacitor because they are the linear elements. In case of inductor, if the input current is I, then the corresponding voltage is V will be equal to the L di by dt. If I is scaled by a factor K, so the output voltage will also be scaled by the same factor. The same holds true for the capacitor. So therefore the homogeneity suggests that if the input is multiplied by a constant K, then the output is also multiplied by the same constant K. Additivity, that is, has to be analyzed if suppose say corresponding to the one input I1, there is a output V1, corresponding to the another input I2, there is a output voltage V2. So if we are giving the third input, which is the sum of these two, I1 plus I2, then the output voltage will be equal to nu I3 multiplied by R, which is equal to the I1R plus I2R. This particular is represented as sum of the old responses V1 plus V2. So therefore the additivity suggests that the response to a sum of input is the sum of the responses to each input applied separately. So this we have seen for the single elements. The same holds true for the linear circuits. The linear circuit must comprise of the linear circuit element, linear independent sources and the linear dependent sources. Output of the linear circuit is linearly related to the input. In this particular, we are saying the voltage and currents, they are related to the input in the linear manner. This particular is not applicable to the power because that particular is constituting a non-linear relationship. So let's say this example, find V0 for the input current as 15 ampere and 30 ampere and validate whether the circuit is linear or not. So this is, you can see the parallel arrangement of the resistors supplied by a source. So you can easily find out the current through the desired resistance. That current is multiplied by the voltage, so that particular is giving you the output voltage relationship. So for the given value of problem, it is 2 Is upon 3. For the Is is equal to 15 ampere, the output voltage is coming out to be 30 volt. When say the input is 30, output voltage is 20. So you can justify the scalability property that this first input is multiplied by a factor 2, and that's why the corresponding output is also multiplied by 2. Or just to give a spin of the additivity property, you can say first current is 15 ampere, second current is also 15 ampere, correspondingly the V1 is equal to 10 volt, V2 is equal to 10 volt, and when say the combined input 15 plus 15 30 ampere is taken, then the output voltage is equal to V1 plus V2, which is 10 plus 10 is equal to 20 volts. So in that way you can suggest that circuit is linear. With this background, we will be in a position to discuss the superposition theorem. This superposition is applied when say the circuit is consisting two or more than two independent sources. So that particular is important. Now there are situations where we wish to find out the contribution of individual source. So when say the contribution of individual source is to be counted, then we have to consider independent source in one by one manner. And when say we are interested in considering the source one by one manner, then the other sources has to be turned off, or you can say they are to be made ineffective. So just to turn off the independent sources, there is a procedure, well established procedure, that to turn off the independent voltage source, replace it by a short circuit, and to turn off an ideal current source, replace it by an open circuit. So here the question is independent ideal voltage source. Please be mindful regarding the terminology. This particular is independent, so it is not a controlled source. Second particular, the ideal. So ideal means it is not having any internal resistance. If that is the situation, we are replacing it by a short circuit. If suppose say it is specified that the source is a practical voltage source, so the practical voltage source is represented first as a combination of the ideal voltage source and the series resistance, and B simply is short circuiting the ideal voltage part. So basically the practical voltage source is left with a internal resistance only. Similarly is the situation when say there is a current source. So when say it is a practical current source, it is represented as a combination of the ideal current source and the parallel internal resistance. So the ideal current source is to be made open circuit. Now the dependent sources are having the influence where say the parameter is depending on the other voltage or current, so they are to be left unchanged. So here only the independent sources are considered one by one manner, in a one by one manner, and the others are turned off, where say the dependent sources are left unchanged. The superposition theorem states that the voltage across or current through an element in a linear circuit is the algebraic sum of the voltages across or the current through that element due to each independent source acting alone. So please be mindful that the voltage is measured across the terminal or the current through the terminal. So there should not be any confusion regarding the terminology. It is basically the arrangement to compute the voltage or the current associated with an element. Now this particular word statement is translated into the steps through which we can calculate the net voltage or the current through an element. So let's say the circuit is having the n number of independent sources, and as the procedure suggests that we have to count them one by one. So let us say first step, turn off all independent source except the jth source and find the element voltage or the current. So element voltage, that particular is subscript with VE. Similarly the current is with IE. Jth source under consideration, so it is giving a double script nomenclature VEJ or IEJ. Now the above procedure has to be repeated for each independent source one by one. Thereafter we can calculate the net voltage or the current VE is equal to VE1 plus VE2 up to VEN, or IE is equal to IE1 plus IE2 plus IEN. So this particular holds true for the linear circuit. Now as an example, just to demonstrate, here say the two independent sources are considered. One is a voltage source, another one is a current source. Intention is to calculate the voltage across this 4 ohm resistor. So here, when say the voltage source is considered to be acting alone, the current source is open circuited. Correspondingly, the circuit is resulting a simple circuit which is just like a potential divider. So the voltage across this is calculated, and that we are designating as V1. So that particular is coming out to be 2 volt. When say the current source is acting alone, the voltage source is short circuited. This is working as a current divider. So the division of current is taking place, and you will be able to calculate the current through this resistance, and the voltage across that is calculated. Now finally, when say we are applying the concept of superposition, so we will be getting the value like 10 volt. The same you can validate by the nodal method or any other method of the choice. This is another example where say two independent sources, one voltage and one current source, another is having a dependent source, so that particular is present, and the intention is to calculate this node voltage which is designated as Vx. Now it is, if suppose we are looking to this dependent source, this value is also depending on the same node voltage likewise. So when say the voltage source is acting alone, the current source is open circuited likewise. The resulting equation is solved by the nodal method, and that particular is given the nomenclature Vx1. So the nodal equation is Vx1 minus 10 upon 20 plus Vx1 upon 4 minus 0.1 into Vx1, because this particular is injected into the node. So that is resulting into the 0 value, and when say we are solving, this is giving you the value Vx1 is equal to 2.5 volt. When say the current source is acting alone, the voltage source is short circuited. Likewise, you are writing the nodal equation. So Vx2 upon 20 minus 2 plus Vx2 upon 4 minus 0.1 Vx2 is equal to 0. So that 2 is taken on the right hand side, the resulting equation is likewise. So Vx2 we will be getting 10 volt, and ultimately the superposition is established, which is suggesting 12.5 volt. In the third example, we have to calculate the VAB using the superposition theorem. Here says there is an open circuit, but this is a controlled source. So the controlled source is in this question, it is depending on the open circuit voltage VAB. Again say we are going by the same procedure. When say the voltage source is considered alone, the current source is open circuited, so that particular is removed. Now here say there is no interconnection, so there is no closed path, that's why there will be 0 current in this. However, the KVL still holds true, so that particular is applied while say oriented around this particular closed path manner. So minus 4, that is a voltage rise, this is experiencing a voltage drop of 3 VAB1, there is a voltage drop of VAB1. So that particular is giving you the value of VAB1 is equal to 1 volt. Now in the second case, when say the current is the only effective source, so the voltage source is short circuited, likewise the equation will be, so you will be having this as a node voltage. You can write the expression, nodal expression, so VAB plus 3 VAB2 divided by 10, this is injected into current, so minus 2 is equal to 0. That particular is suggesting VAB2 is equal to 5 volt, and you can apply the superposition concept. Fourth example, this particular, here we have to calculate the Vx using the superposition. So it is having two sources, one is voltage source, another is the independent current source. This particular is a controlled current source, and the controlling quantity Ix, which is the current through the resistor through which we have to find out the voltage. So as a procedure, we have to consider the independent sources in one by one manner. So with only voltage source, current source is open circuited, the equivalent is like this. So just to find out the equation, we have to have a KVL equation around this. So this is a current source, it is injecting 5Ix here, Ix is directed likewise. So the current through the 2 ohm resistor will be 6Ix with a polarity such that the left terminal will be positive, right will be negative, and so on. So in that sense, the equation is resulting into minus 10 plus 1 into Ix plus 2 into 6Ix plus 4 into Ix is equal to 0. So that particular is leading to the Ix value as 10 upon 17 ampere. With only current source, so the schematic is looking like this. Here say this voltage source is short circuited. Now just to solve it, you have make use of the source transformation, so it will be looking little simpler. In the source transformation, the current source with a parallel resistance is translated into a voltage source and the series resistance, and you are now writing the nodal equation. So VA is the node voltage. However, once you are able to write the equation, you are getting the idea that this VA is nothing but it is minus of 1 into Ix. So that particular is written. This is made a substitution, so the Ix value is calculated likewise, and once you are applying the concept of the superposition, you can find out the value of Ix as sum of this 10 by 17 plus minus 12 by 17, so that particular is minus 2 upon 17 volt. So in that way we are able to solve the circuits. Now there are, say, at the end we have to summarize that this superposition theorem holds true only for the linear circuits, and the linear circuit must consist of linear circuit elements, linear independent and the linear dependent sources. Because of the superposition, we can find out the contribution of each independent source to the branch voltage or current. It is not applicable to the power calculation because that is a non-linear relationship. The only drawback of this particular method is that we have to solve the circuit as many times as the number of independent sources. So that is the drawback. However, the computation is expected to be simplified because at each stage the circuit will be having only one independent source, while say other sources are made ineffective or turned off. Now in this particular process, the ideal voltage sources are replaced by the short circuit and the ideal current sources are replaced by the open circuit. However, the dependent sources are left unchanged. So this is all for. We will be having, say, the next discussion on the Thevenin's theorem. For further reading, you can refer these particular texts.